Hello friends, I am Benedict George. Today I am going to show you the errors in Lorentz transformation. Lorentz transformation forms the basis of general relativity and quantum mechanics. And since the basic equation of Lorentz transformation is wrong, therefore it has a ripple effect on the general relativity and quantum mechanics. So let us see what are the errors. So there are 4 errors in Lorentz transformation. First error is that the equation of Lorentz transformation is an inequality. So the equation x prime is equal to gamma x minus vt is not an equation, it is an inequality. The reason behind it is that x minus vt is actually equal to x prime. So this equation will only be an equation when gamma is equal to 1. If gamma is greater than 1, then this becomes an inequality. And in Lorentz transformation, they have given gamma, they have derived gamma as gamma is always greater than 1. Therefore, this whole equation becomes an inequality. This is the first error. The second error is this x minus vt is actually assumed wrong by Lorentz to be x rest. What he wanted to do is that he wanted x prime is equal to gamma x rest. Why? Because once you multiply a transformation factor with x rest, the rest value position of any particle, then it should become the extended, the transformed position of the particle, particle P. But this x minus vt is not equal to x rest. Therefore, this equation is wrong. Third, this is first, this is second, this is third. In third error, this equation of Lorentz transformation x prime is equal to gamma x minus vt. In this x also contains the transformation, and this transformation is additionally added and additionally multiplied by the another transformation. So actually this is transformation factor. Once it is multiplied by transformation inside, then it becomes the length which has transformed from OP, it will be transformed to OP prime, but actually this equation becomes this. So this whole part is wrong. So that will also, I'll prove it to you. Then the fourth error is that they had This is the point P at rest. When it moves with velocity v, then it is transformed to P prime. They have transformed point P to P prime, but they have not transformed O prime, that is the origin, to O1 prime. This they have not transformed. Because of this, there is the error in the results of Lorentz transformation. Next, we will take one by one. The first error, this is x prime is equal to gamma x minus vt. This is the equation of Lorentz transformation. Now, let us see x minus vt. So x, what is x? X is from stationary frame to the moving frame. This is a point P prime. We will measure up to here. This is the value of x we are getting. How we are getting? We'll send a probe from stationary frame into the moving frame and we will find the position of point P. So you will get the transformed position of point P, and that they have considered as x. So this is x. So x prime is equal to, we put the value of x is nothing but O prime P, P prime. So gamma O prime plus O prime P plus P prime. Minus, what is Vt? O prime. So O prime. You cancel out O prime. So you get gamma O prime P plus P prime. Right? Now, what is O prime P plus P prime? O prime P plus P prime is nothing but x prime. And they have proposed the value of gamma to be greater than 1. Gamma is always greater than 1. If it is greater than 1, then this equation becomes an inequality. So first point is proved. Next, error 2, that is x minus vt is not equal to x rest. Actually, this x minus vt in the equation of Lorentz transformation is taken from the Galilean transformation, and in Galilean transformation also this equation is wrong. So let us see how it is wrong. So we will take Galilean transformation, figure A. In figure A, both frame of reference are at rest, S and S prime at rest, and their origins are coinciding. That means O and O prime are coinciding. And there is a point P in S prime frame of reference. When you measure the distance OP or O prime P, that will be equal because origin are coinciding and they both are at rest. So we'll take OP is equal to x, O prime P is equal to x prime, and all are equal to x rest, that is OP, O prime, all are equal and they will be commonly known as x rest. So when S and S prime frame of reference are at rest, O prime x prime is equal to OP is equal to O prime P is equal to x is equal to x rest. Other dimensions we are not considering because the movement will be only there in x direction, that is on x-axis. So other dimensions we are not considering, we'll keep it as it is. Now in second figure, this S frame of reference is at rest and S prime frame of reference is moving towards right on x-axis at v, velocity v. Right? So we are not considering other dimensions. So y prime, z prime, t prime, we will keep it like this. There is a problem in t prime also, but I'll let you know when we will do time dilation. So let us see this equation, x prime is equal to x minus vt, which is proposed by Galileo. We have written this equation here. Now what I propose is x minus vt is not equal to x rest. Actually, in Galilean transformation, the position of point P from O or O prime, there should be no transformation. Once there is no transformation, this x rest should be equal to O prime P. It will not transform from P to P prime. Actually, it should not. What is proposed by the Galileo. But what happens? What happens? Actually, the Lorentz transformation said or tried to prove that this transform from this point P transform from P to P prime. So we have to prove in Galilean transformation that this length or OP is equal in the moving frame of reference. That has to be x rest. So x prime is equal to x minus vt. What is x? From this figure, because the figure, this s prime is in motion, x will take the value of x. When you send a probe to find the distance from this frame of reference, that is stationary frame of reference, to the moving frame of reference to point P, because it has transformed from P to P prime, the distance will include P prime, that is transformation also. So then we have to use what is x, O prime, O x, O P, O prime P, and P prime. So O prime plus O prime P plus P prime, and minus what is Vt? Vt we already know, O prime. So O prime. Right? Now we cancel out this. So what is left is O prime P plus P prime. Now you see O prime P. What is O prime P? Here it is equal to x rest or OP or O prime P in the stationary frame of reference. And what the Galilean transformation says, there should be no transformation. So this length has to be equal to this length. So O prime P is actually equal to x rest and this P prime. Now when you verify this x minus Vt is not equal to x rest. It is addition of P prime. Therefore, x minus Vt is not equal to x rest. This is the second error which has proved mathematically. Next, now you see practically how when you put numbers into the values, then how the transformation takes place and how we can prove this x minus Vt is not equal to x rest. So there is x rest. This is 5 meter. Right, P prime 1 meter. There is a transformation of 1 meter P prime. So 1 meter. Time we take as 1 second. After 1 second we calculate. That we will calculate from clock from here. Then x. When you send a probe, it will not give this position because the point P has already transformed to this position. So it will give the distance x, that is 16 meter. So you will get 16 meter distance from here to P prime. Right? Now when you use this equation, x prime is equal to x. X is what? 16 meter minus v, velocity is 10 meter per second, right? And time we has taken as 1. So that is 6 meter. See, x prime, value of x prime is what? 6 meter. And value of x rest is 5 meter. So this x rest is not equal to x prime. Therefore, x rest is not equal to x minus vt. So I had proved this one by using numbers. Next, now if these transformations are not correct, which I had already proved, then what will be the correct transformation? The problem with Galilean transformation is that inadvertently they have taken p and p prime in their calculation, that is in x. So we have to remove this p and p prime. So we have to include only values up to this p. So that transformation is not included, because in Galilean transformation there is no transformation of point P to point P prime. The value of x rest has to be the value of x prime also. So for that you have to make certain changes. So instead of value of this x from here, that is O to O prime, we have to only take the value of x from here to here. And we need not send a probe to find the value OP, because we already know the value of O prime and OP. O prime is Vt you are getting, and O prime P is the x rest. So you have to use x is equal to, you have to take as O prime plus O prime P. That's it. So when you put this value of x in the equation given by Galileo, then x prime is equal to O prime plus O prime P, that is the value of x, minus Vt. What is Vt? Vt is O prime. So O prime, you cancel this, you get x prime is equal to O prime P, that is equal to, what is O prime P? That is equal to x rest. That is equal to x rest. So there is no transformation in Galilean transformation equation. So I propose that x minus, instead of x minus Vt, we should write x rest. Finish. And take the value of x from O to P, not O to P prime, no, only from O to P. We can theoretically take this, no practical probe is required. Then this will become a right equation. Now next. Now since this x minus Vt is not equal to rest, then because it is based on this equation of Galilean transformation. So in Lorentz transformation, you have to use, instead of x prime is equal to gamma x minus Vt, we need to use this equation, x prime gamma x rest. Now how it is useful? Because x rest is there, when you apply a transformation factor, then it becomes extended value of x rest, that is O prime P prime. Therefore, but the problem with gamma, there is a problem with gamma. The problem with gamma is that this derivation of gamma, which I'll let you in next videos, that 1 upon under root 1 minus v square upon c square, c square. This is wrong. Whole derivation of Lorentz transformation equation is wrong. Therefore, I propose a new transformation factor, that is beta. And this transformation factor is not equal to 1 upon 1 minus v square c square. It is not equal to this gamma factor, this beta factor. You need to find out practically. Right? Any further query on this, please let me know. Now next. Now the third error in Lorentz transformation. Now we have this equation of Lorentz transformation. If it is true, then x prime is equal to gamma x minus bt. Right? Now, if we extend this equation like that by multiplying gamma, so gamma x prime is equal to gamma x. X is what? O prime. So gamma O prime plus O prime P. We multiply gamma with this also. So gamma O prime P plus gamma P prime minus, we multiply gamma with Vt. So Vt is what? O prime. So this is O prime. Now see, we will cancel this. What is left is x prime is equal to, I'll move gamma out, so O prime P plus P, or I'll not put gamma out because it will give a wrong this thing. So x prime is equal to gamma O prime P plus gamma P prime. Now see, O prime P is what? O prime P is x rest. It's okay. When you multiply O prime P with a transformation factor, you get the extended length of x prime. See? So up till now, this equation is almost correct. But this gamma factor, transformation factor, is also being multiplied by PP prime. First of all, this PP prime, that added value is wrong. You should not add, because this will give the extended value, only this part of it. But you have added PP prime and you have multiplied that PP prime with transformation factor. So again you have added. So what happens? What length you get? You get the length of PP prime with this. Then you get PP prime and multiply with gamma transformation factor. So there is PP prime and then some factor is also added. So your equation was right up till here. This was up till here. But you have added PP prime more into it, and one more, the gamma multiplied by PP prime. Right? So gamma का multiply this one. Right? So you have transformed PP prime more. That's why this I have shown you that PP prime is double transformed. Right? Next. Now the last one, the fourth one. Now in this frame of reference which is moving, what they have done is they have assumed that point P has transformed to point P prime. But they have neglected that any point on the moving frame of reference will also be transformed equal to the transformation of PP prime, because any frame of reference will also be the locus of points on in the frame of reference. That means that O prime and O1 prime, that will also be transformed equal to PP prime. So they have neglected it. Now see, O prime, O1 prime is equal to PP prime. I'll write it correctly, PP prime. This transformation they have neglected, and once this transformation of point O prime happens, that means that there is no change in length, because a observer who is sitting here will find length, will calculate length from here, this, because it has already transformed from here to here, and then this length this was like this, is O1 prime is equal to O1 prime P prime is equal to X rest. See, in next videos I'll show you that there is the length contraction is a farce, and here also I can show you that there is no change in length, there is no change in the position, actually length. So only with respect to this frame of reference there is change, there is shift, but length does not change. It does not change. There is some shifting. What theoretically they think and what practically they find, there is shift, but there is no change in length for this frame of reference, because anyone who is sitting here will calculate the length of P prime from this frame of reference, and he will find frame of reference here and calculate. There will be no change in length. So length contraction is wrong. So I given this 4 errors. Kindly go through all these 4 errors, and if you find that it is wrong, let me know. The first person who will be pointing out that my theory is wrong, so I'll give $1,000 reward to that person. And friends, if you find that my theory is right, then kindly share and give your suggestions also. You can send some critical notes also to me, and if you find it to be correct, then kindly share to your professors, your teachers who are expert in general relativity, Lorentz transformations. If graphically if you check, then you will find a lot of differences. Don't go through only theoretical part, just see graphics, the graphs which I have made, and you can find these graphs, right? And you critically think over it. Even what I propose, you critically think that from my point of view, and critically think from the point of view of Lorentz Einstein, right? So kindly share with it. Then if you give your critics or your words on it or your suggestions on it, I am going to develop a new theory of general relativity which will be helpful in the quantum mechanics also, right? Friends, I have written some research papers on this, and I have sent it to lot of universities, their professors, but I have got no response. Maybe they are taking time to read or they are too busy. So kindly send to these videos to professors of these university so that they find out where I am making mistakes. So all these equations of Lorentz transformation and Galilean transformation you'll find in almost all the books of on general relativity or relativity. So I have taken notes from some of the books and on the net, lot of books I have referred. So I am giving you few of the references. These are there. You can find it out. Mostly this reference is most important. This is from the professors on MIT. Thank you so much for watching.